We are happy that you are joining us today for our webinar, Lightning Control with KNX and DALI. In today's webinar, we will be sharing practical knowledge for planning and integration. A few organization notes. You can ask the question at any time using the chat function. Here you found the question mark in the top on the webinar page. We will be happy to answer them by the end of the kapitel. The webinar today will be recorded and made available to everyone afterwards. We are your speakers today. My name is Frederik Riedel. I am the head and trainer of the technical service at Elsner Elektronik, and I'm your contact for all your questions about our products.
So a warm welcome again from my side as well. And my name is Karim Boudiab, and I work as an application engineer at Elsner Elektronik. And as a part of my daily work, I focus on the technical aspects of the product's applications, in addition to providing support for our customers regarding the KNX products and their applications.
Then we want to go to the first page. Maybe you know the feeling, warm lights help us to relax and cold white light wakes us up. No imaging adjusting the light with one touch, so it always feels right for you. That is what today is about. Smart lighting controlled with KNX and DALI. Today's learning goals. Understand and apply the DALI fundamentals correctly. Plan lighting systems effectively. Save energy through automation. And implement DALI function in practice. Now let's take a look at our agenda. First, we will start with the basics of DALI and DALI 2. After that, we will look at energy saving with automation. We will move on to constant light control and lighting design. Next, we will give a product overview. Then we will look at commissioning and configuration from the DALI. And after that, we will continue with application and practical examples. And finally, we will finish with troubleshooting in DALI.
So now we would like to inform you about the basics of DALI, including DALI 1 and DALI 2, which is the next step in DALI. So why should you use a DALI system? A DALI gives you several key benefits for modern lighting. First, it helps create a comfortable and pleasant atmosphere throughout the precise dimming and smooth lighting scenes. And second, it reduces energy consumption by using features like constant light control and presence detection. It also allows individual control, where every light can be addressed and adjusted separately or within groups. We have to mention that it is highly scalable, whether it's a hotel, an office, or an industrial building. It always also keeps the flexibility because the changes can be made through the software instead of the hardware rewiring. So what is DALI exactly? DALI stands for Digital Addressable Lighting Interface. It's a standardized system for controlling lighting defined in the IEC 62386. It allows to control devices like sensors, switches, or gateways to communicate directly with the LED drivers or ballasts. The system runs over a simple 2-wire bus, which does not care about the polarity and works alongside the regular main supplies. So one of the biggest advantages is flexibility, especially with the DALI 2 certified devices, where different devices from different manufacturers can work together seamlessly. So DALI 1, as we already talked as general information about DALI, those are the bases for DALI 1. But we have to add one more aspect, and more for this standard, that it was mainly tested by the manufacturers themselves and not by an external third party. And we also keep the flexibility and the manufacturer independent, so every manufacturer can still produce their own devices. and they should work together with the same project. Now we move to DALI 2, which was the next step in the DALI standard, and it's an extended version. It's also refined with the same under the same certificate IEC standard, which is the 62386, but by the DIA. And the DIA here is the Digital Illumination Interface Alliance. And this DALI 2 ensures the devices from different manufacturers work together reliably, so interoperability is consistent. And control devices like buttons, sensors can now be fully integrated into the system, and a multi-master capability allows several controllers to operate at the same bus. This improvement makes DALI 2 more reliable, flexible, and suitable for complex lighting installations. And we should also mention that DALI 2 certified device is backward compatible, which normally allows a DALI from a previous version, which is DALI 1, to work alongside. Now, what is a DALI control gear? A DALI control gear is like a ballast or an LED driver are within the same IEC standard certified. It runs over a simple two-wire bus without polarity. As you mentioned, it's polarity independent, which makes the installation straightforward. And each device is fully addressable, so you can control it individually, in groups, or via broadcast. It also supports scene control, which are saved directly on the device. Another key feature is the status feedback. For example, reporting the lamp failures or the operational state. So the DALI control gear is compatible with various control devices, such as buttons, sensors, or gateways, especially under the DALI 2 interoperability. And we're moving to the DALI installation, and the key factor here is the cable. So when installing the DALI bus, the cable diameter is the main factor determining the maximum length of this bus. For example, a 1.5 square millimeter supports up to 300 meters of bus. So it's worth noting that the installation with 5 by 1.5 square millimeter cable is allowed, since DALI does not require a self-supply. And following those limits ensure like a stable communication and reliable operation of all the devices on the bus. Now we're going to move to the DALI bus structure. So a DALI line usually can connect up to 64 control gear devices, like ballasts or LED drivers, and up to 64 control devices such as switches, sensors, or gateways. For example, our Elsner DALI L1 or L2 is currently supporting up to 32 sensors and 64 control gears. The bus is usually polarity independent and operates in a voltage range between 7 to 22.5 volt, and typically it operates between 16 and 20 volts. And it's always recommended to use one power supply per bus to ensure a stable operation. DALI supports flexible topologies like a line, star, or tree, so the installations can adapt to building layouts easily. But we should mention that a ring or a loop within the DALI bus is forbidden. A DALI broadcast. The DALI broadcast lets you control all the devices on the line at the same time. Since no individual addressing is required, commissioning is usually very fast and simple. It's ideal for straightforward applications where all the lights should behave the same. So we think of it like in a small example. So if I ask everyone in this webinar to stand up and sing a song at the same time, that would mean that the broadcast command goes to everyone and is executed simultaneously. So broadcast also save programming effort as no groups or scenes assignment is necessary. A limitation is that you don't get a feedback from the individual devices. So some examples for broadcast control would be street lighting, industrial building, sport halls, and typically any large-scale lighting system where the lights are usually expected to react the same. A DALI multicast. This is another feature in the DALI 2. This allows you to control only specific groups on the device line, specific groups of devices on the line. So you can dim, switch, or recall scenes for that group and get a feedback on a status or error. So the same similar example, we would say if I ask now only all the system integrators in the webinar to stand up and sing a song, then the command would only apply to that selected group and not to everyone. So we can say that multicast is ideal for rooms, zones, and grouped lighting, offering much more flexibility than the full broadcast. A DALI multi-master is another concept. So a DALI multi-master allows multiple control devices on the same line to send commands without a fixed hierarchy. So the bus protocol coordinates everything to prevent collisions between those masters. So switches, sensors, and gateways can be all active at the same time. And all masters can read the status feedback from the devices, and if one master fails, for example, then the line continues to operate normally. This setup would increase the flexibility and reliability, especially in the large or complex installations. So in case you have any questions regarding the basics of DALI, kindly use the question function in the webinar.
We give you a few seconds to write your question, and then we will answer them if there are questions, and if not, then we want to forward with the webinar. Okay, we received no questions, so I think it's all fine with the first part of the DALI overview from Karim, and so I want to follow with the next capital. On the next slides, I'd like to show how different lighting automation can help save energy. In this graphic, the lighting is switched on manually without any automation. As shown, the lights stay on for total 12 hours without any control. The next graphic shows how automation works. The lighting are grouped and switched on and off with timers, which can save energy. With this easy automation, you can save up to 30% energy. You can see this in the dark blue and in the bright blue graphic. The bright blue shows the old energy consumed, and the dark blue the new energy consumed with the automatic. We can future improve the automation by adding a presence sensor. This allows the light to turn on and off based on time and presence. This automation reduces energy even more, saving up to 50% compared to basic manual control is possible. The final graphic illustrates the optimal automation. Lighting is now controlled by time, presence, and constant light. This all allowing to save energy up to 65%. Also light automation, it's very important. Do you have any question about this capital, energy saving or automation? So use the chat function and then we will answer them in a few seconds. I not get some questions about the last topic, but one guy write us that the transmission is not perfect, so it's sometimes a problem on the receiver side. But the webinar today is recorded, and so after the webinar we will send the recording on all after we prepare this. And so we want to continue with the webinar. Thank you for the feedback. The next capture will focus on constant light control and lighting design. What is constant light control? Constant light control brightness is automatically adjusted to the room conditions. Sensor measure brightness at the workplace or in the room. Energy saving lighting is only operated as brightly as necessary. And we have the optimal automated in combination with presence detectors. Here I have a graphic with an example on the constant light control, and I want to explain how it works. You see in the left side a window in the room, and through the window there comes daylight in. The daylight is mixed with the room lights and fall on the desk. The light from the desk reflects to the light sensor on the top, and the sensor checks the target and the actual brightness and adjusts the lights if it's needed. And you can see on the top the 3 lights. The area shows different dimmed values. And the values can different depending on the light. And for example, you can use a threshold, and with the threshold you can switch up a light group on the window side if you have another light from outside. And that all can be automatized with the constant light controller. So that's the working of a constant light regulation. And on the next page, I want to show you some important knowledge for the constant light control, because you have to look that these points are correct if you want to use the constant light. For example, the room characteristic must not be changed without adjusting the settings. If you have the constant light sensor installed and you moving the table so the reflection change from the object, and so you have adjust the characteristic of the constant light. Do not mount the sensor directly on a natural light source. The surface below the sensor should reflect light. Dark surfaces reflect very little, so that are not proper. Shield the sensor from the daylight or the lamps. And if you look, these points are correct, so the constant light regulation works very perfect. Okay, before we talk about lighting design, I want to show how much the color of light can affect our well-being and even what we buy. In supermarkets or shops, different light colors are used on purpose. Cold white light is often used in the fish section, warm amber light for baked goods and cheese, and the red light for meat. The type of space also matters. Office, work areas, and home use very different lighting. And on the graphic you can see the different light colors with the different areas in a supermarket, for example. We are looking at a training room where we will plan the lighting. The room has a blackboard and 2 windows on each side. Daylight comes in through the window on the right and the left side. The circle on the graphics shows where the lights are installed in the room. The first step is to organize the lighting into different groups. In our example, I prefer to have 3 main groups. My first group is along the left window side, over the blackboard, and along the right window side. The 6 center lights may still be needed, so they have their own group or individual control. I arrange the groups so that when enough daylight enters through the windows, the side groups can be dimmed or switched off. In the next step, the training room was split into areas. With conventional wiring, this would require a lot of electrician work to change this. With a DALI system, a system integrator can easily set up lamp groups and adjust them to the new room layout. This is very useful for offices, schools or companies where room usage may change. A possible new grouping is shown in the graphic. You see here the group 1, a group 2 for the left part of the room, and for the second room see a combination on individual lights and a third group. Also very easy to change this with a DALI system to the new room layout. In the following graphic we see our planned training room. Now we want to extend the room with a constant light controller, the Intra-Sewi from Elsner. The Sewi sensor for the constant light control can be placed as shown in the graphic. In this position the sensor measures daylight indirectly. In addition, the light groups near the window can be switched off when a brightness level is reached. This provides an excellent way to save energy in the room. Here you see the both groups of the lighting again. Do you have some question about the constant light control and lighting design? I want to give you a short time to use the question button, send us the questions and we will prepare and answer the question. Okay, we now receive more questions, so we can go on with the webinar. I think in the last part after the webinar we have a little bit more time to answer your questions. Then if you have questions following the webinar, then you notice this us or send us, and we will answer them in the next break. In the next topic, I want to give you an overview of our Elsner products. Here you can see our two DALI devices. We have the DALI L1 with one output for 64 DALI operation devices, and the DALI L2 with two DALI output channels, each with 64 DALI operation devices. And more details I want to give you in the next page. Here you see the device again. The DALI L2 and L1 devices are the interface between the KNX world and the DALI Lightning Bus world or systems. The DALI L1 and L2 have a line for one or two lines for 64 DALI devices, and you can also use 32 DALI sensors. Broadcast, group and individual control, it's possible. And you have data type 8, which supported color temperature or color control. And the device is a new standard, so you also have DALI Secure. I want to show you the device on our camera. I changed the side, and here you see it in real life, how the device looks. I think it's a very easy control device. You see some buttons, you have the connections on the devices, and it's for the installing in the electronic boxes. Okay, I switch back. In the next section you see the Intra-Sewi. It's our presence brightness sensor. This sensor have an integrated presence detector and constant light controller. You also have integrated temperature, humidity and a light sensor, and it's also included a temperature P controller, so you can use the sensor to detect the room temperature and control the temperature in the room. So it's very easy to use it in all projects. And you have styling installation. I think we not receive some more questions, and so we can continue with the webinar. If you have questions, use the function. The next capital want to explain from Karim.
So hello again, and this capital will be about the commissioning and the configuration of a DALI system with KNX. So commissioning. Those are the three main steps of commissioning a DALI system with KNX. So we would say it's a relatively simple job to do. First, we set up the DALI configuration with the wirings and the devices addressing. And then we set up the KNX configuration, also including the wiring. And then finally, we have to link those two systems using the gateway so the KNX can control the DALI devices smoothly. But fully commissioning the DALI devices with the KNX is not only possible using the ETS5 or the ETS6 alone, where ETS is the engineering tool software used for KNX commissioning. So we need an additional tool in order to perform that, which is the DCA. By adding the DCA, our device's configuration app into the DTS, it will appear directly into the software and will allow an easy configuration of the DALI device. Broadcast commands can still be used even without the DCA. The app also provides monitoring and diagnostic functions, making it simple to check the device status and troubleshoot when needed. So this is an overview of how the DCA will look like, but I think we will go now into a more detailed live example on the ETS and the DCA. So here we can see the ETS software. This is the ETS6, and here we have different devices in our project, and our main concern is the KNX DALI L2. Within the DALI L2, we have the parameters, and as you can see here, the extension is the DCA. We will get to it later. So for the parameters or the settings of this DALI device, or the DALI gateway device, to be specific. So we have the information of this device. We can go to set general settings, some manual operations, activate or deactivate, activate status indicators, and mainly, and the most important part, is the DALI system settings. And here we can see DALI system 1 and DALI system 2 because this device is an L2 and supports 2 DALI lines. So we go through the first system, we have the general settings, and here we can set some general functions for the DALI device or for this DALI line, including some feedbacks and the type of the addressing mode, which here we chose 16 groups or up to 16 groups and up to 64 devices. You can choose other, and that is upon to the project requirements. So, and then the next step would be configuring those groups or the single devices. And the configuration for groups and single devices are almost the same. So for the group, you can choose the group numbers, how many groups do I have in this project, and then choose the names for each group, and then choose the function for each group. So if it's a brightness only, or a color, or a brightness and color at the same time. We'll go into more details into the single device, and here we can choose also how many devices are we using, or we want to prepare to be used in the project. And here we selected only one. The name is the ballast, and the type of this device is DT6 because it's an LED module. You can also choose different types depending on the project that you are using and the actual devices you have. In addition to those settings, we have the HCL or the human-centric lighting, and those are some matrices. I'll show you here in a moment. And in this matrix, you can set different color temperature with different brightness for a different time. And this, like a schedule, you can activate for a single device or for a group. And same for the temperature, you can use a color. And here it's called the color transition mode. It has the basic same logic, a matrix with a different color, different brightness for different time, and it's activated when you select a data type or a type of device that allows a color transition. In addition, we have the scene function where you can create your scenes, set what values for what scene. And now I'll show you a little bit on the DCA. So a DCA will usually start like this. You have the welcome page, and here you have like some briefings about what is available in this tool. On this side, we have the device commissioning, the DALI device commissioning, which are the ballasts usually, or the control gears. And this, in this window, you can do this commissioning. In the next window, you can do the sensor commissioning. In this function, the DALI test, we are able to use some troubleshooting functions to test our project and our installed devices. The export and import are mainly used when you need to have the same configuration for multiple DALI devices. So in case in an hotel, for the different levels or different zones or different areas, you have the same configuration. So you don't have to prepare all this setup again. You have to import it from your previous project. And at last, you have the documentation, which is a PDF document about your project. And of course, you have the help function, which has everything or almost everything that you could need while using this DCA. So this is an overview, and we'll get later to see the commissioning part using this DCA. Okay, so if you have any questions about the configuration or the commissioning, kindly use the question function in the webinar, and we will answer you shortly. So I will continue, and I will receive your questions, and then I will answer you at the next break. So we will go through the applications and practical examples for the DALI system. So as an example, we have office spaces, schools, and public institutions. In addition, supply and retail, hotels and catering or restaurants, residential buildings, or so-called today the smart homes, as well as the industries and the production areas, and in public buildings or outdoor areas. So it could be said that anywhere a lighting solution is needed, DALI is ready to provide it. So a status message on a KNX bus. This is an important concept to use and an important function to use. A status message can be generated and processed for efficient use in commercial projects. So a distinction is made between the light source itself and the control gear or the driver. And this allows the repair requirements to be determined beforehand and the replacement to be planned efficiently. And now we'll go to a KNX lighting control tunable white application. So now here, as you can see in the picture, we have a modern application example using sensors on the KNX side and DALI on the other side. So on the KNX side here, we can see the Corlo Touch 5-inch and the KNX M2T, those are Elsner devices, as well as the KNX DALI L1, which is the gateway. And here as the device or the ballast is an LED driver supplied from an external 24-volt DC. On the top right side, we can see the power supply for the KNX bus, and we can see a KNX CP IP gateway. It is, here it's a coupler, and it's to connect this system to further with other lines. Okay, so this is a real life solution for residential buildings or home theater or even office spaces. And now we will show you a real life example. We have a setup here and we'll show you how will it actually behave. So as you can see, similar to the previous picture schematic, we have the DALI device, we have the push buttons. This is the Sewi from the previous example, and here we have the DALI ballast. Here on the Corlo, we can see that we have we are able to control the light by just sliding and choosing the selected value. So now we're around 40%. If I go to a higher value, then the light will go directly to a higher value. And this speed of the transition is usually set in the parameters in the ETS. So you can make it slower or faster. Similarly, you can say turn off or turn back on. So this was a short example of how will it look in a real life. So this application, as we mentioned before, is not possible if you only use the parameters in the ETS. We have to use the DCA. So in order to do that, I'm going to show you also a small live description or demonstration about how we can do this. So in this part, we now go to the DALI device commissioning. So we know beforehand we have prepared the DALI device. We selected one DALI device as an individual. We have the name for it and we selected the data type. And here we have the DALI commissioning. On this window, we have what we have already created in the parameters. So these slots are done already. What we will do now is to search for a device. Usually this window will be empty, completely empty when you first start the DALI commissioning. And then you do a search for device. Your devices will appear here. All the lights connected on the bus, on the DALI bus, will be visible on this side. And then you can easily drag or drop to the electronic ballast, or you can select here the single device that you want and then select the ballast that you want and simply assign this ballast to the correspondent slot. After this is done, you just have to click complete commissioning and then everything will be configured correctly. Similarly, you will have to do for sensors. You will have to create slots in the ETS, then search for the sensor, assign, and complete commissioning. The DALI test could be useful also if you want to detect one light or to check if the lights are responding or not. So this was an overview about our DCA. So we'll continue now with our capitals. And in case you have any questions concerning the DCA, kindly share them in the question.
Okay, I see we not received some more questions, and so we continue direct.
Okay, so troubleshooting in DALI. And for this topic, we are going to use some real life scenarios or cases that you could expect to have on the site. So the error case status output, as we mentioned before, it's an important thing. And the DALI gateway can output multiple status messages for the error cases. For example, the DALI system error, or the DALI error per group or per individual device, or per the ballast itself. And for error case 1, we have a light that remains off despite the control commands. So we have in a room multiple lights, we turn on or respond but one. What could be the possible cause? So in this case, we would expect that the supply voltage is missing for this device, or incorrect parameterization, or the control gear device is defective, or the light itself is defective or broken. And in an error case number 2, here we have the light is permanently switched on at 100% and does not respond. So what could be the probable cause for this case? In this case, we can say that the DALI bus is interrupted, or an excessive voltage drop is on this device, which is preventing it from going to the value. Or the power supply or the fuse is defective. Or we can always remember to check our parameterization. In error case number 3, so we have one lamp in a room that cannot be controlled individually. So you click your button, you have 2 lamps switching on. Maybe to different values, but both are switching on or switching off at the same time. What could be the problem? In this case, we would expect that devices have the same address. How can this happen? It's usually if you have an installation site and then you had some lights removed, or you had a new redesign. So you removed some lights, you put them in the storage area, and then after a while you got those lights and place it back in the system, and it's still addressed. It holds all the information it has, but you have a new device which has the same address, and this will cause the devices to behave at the same time. So for error case number 4, we have this in another room, different lights, we switch on, some go to 100, the others go to a different value, which is not what we want to reach. It looks like a little bit not bright. So what could be the possible cause? Here we would expect that the maximum level parameter is not being configured correctly. So you have limited the brightness, the maximum limit of brightness for this lamp. And so it's reaching this and not being able to go any further. So in case also you have any technical questions concerning the troubleshooting, kindly write us in the question.
Okay, we are in the end of our webinar today, and we want to give you a few minutes to ask or to send us your question and ask all the stuff what you want to know. We can share the ETS again if you have some question about the parameters, or if you need some more information about another topic, then ask your question, write them, and we will answer them in the next minutes for all. We will stay here and read your messages, and then we will prepare them in a short time, in a few minutes, and then we will answer them for all. Thank you for the first step. Okay, we receive one question, and the question is from Martin. He asks where we can set the brightness level by bus problem, or where we can set it for the min and maximum value. I not really know which one from both he want to know, but I think Karim can us explain this in the ETS again.
Okay, so go back to the ETS. Okay, so as we can see here, before the general setting, we had the general configuration, and as we are talking about a single device, we then go to the single device settings, which is in this case, this electronic ballast. So as you can see here, we have the minimum brightness value, and we can set it from 1 to 100 or to 99, I guess, or 100%, and then the maximum brightness is set here. So the last case that we talked about, which is set to 50, it's mainly set in this parameter, and the device cannot go any further than 50%. And for the after reset or a bus power restore, we have this reset behavior, and here we can see after bus main voltage return, what is the behavior. So we can select this and choose a specific brightness value. You want the light to switch off, or you don't want any reaction. So you want the light to continue to have the previous reaction. And for what I expect from Martin, or I understood him, is that he needs a brightness value. So you set the brightness value and you choose exactly what you want after this reset, and then the device should behave as you program.
I think it's an important thing to set this correct, because if you have a DALI light in a sleeping room, for example, and you set this to 100% and you had a power reset, then you will be maybe wake up because the light started with 100%, and so it's better in this area to set 0% or switch off. In the other floors, for example, you can set 100% so that you get the light if the power comes back. It's a short, quick example, and yes, I think we answered all the questions, because we not get more questions. So we are in the end of our today's webinar. Thank you for visiting our webinar. It was the first webinar for our DALI, and if you have some more questions after the webinar, you can write me or you can write Karim. You find our contact data on the next page. Also, you find our LinkedIn. You can write us and we can answer you all what you want to know. And on our webpage at Elsner Elektronik, you can find all from the Elsner Academy. There you found the next interesting webinars. We have a lot of new webinars next year, so you can look there and you can maybe visit our next webinars. Thank you for joining us today, and welcome to the next webinar.
Thank you so much for your time, and see you in the next webinar.
We keep this page for a few minutes, and after then we will leave and close the webinar. Thank you for visiting.